Hello everyone. So today I'm going to start with a lecture series of Unit 4, right, which is double and triple integral. Now, what do you mean by double integral? The concept of double integral is an extension of the concept of definite integral, which you have studied in your earlier classes, to the case of two arguments, wherein in the previous classes, that is in your plus 2 classes or 12th standard, you have been studying definite, that is area under the curve, right? That was with respect to only one argument, that is it was given as y is equal to f of x, right? But here in the double integral we shall extend the concept to, that is the concept of definite integral, to the case of two arguments, that is it might be x, y, y, z, right? That is of the form phi is equal to, or any other variable which is equal to in terms of x and y. Now, how to solve these type of problems? So there is a proper way of solving these problems. So that is method of evaluation of double integral. How do you evaluate them? So given a double integral over the region A, or it might be R, you have to find the area with respect to the function which contains two arguments, that is, or two variables x and y, and that is dx dy, which is equal to, wherein since it is what, definite integral, here I have marked definite integral, so having the limiting points of x1, that is x1 x2 and y1 y2. So f is a function which contains two arguments with respect to, that is dx dy. So let me consider this as equation 1. So let us see the cases with respect to this equation 1. Suppose if x1, x2 and y1, y2, all these limiting values, that is upper and lower limit, that is x1, x2, y1, y2, are constants, right? So what will happen? Then the order of integration is immaterial, provided the limit of integration are changed accordingly. So if you have been given a double integral with respect to the function which contains two arguments over, that is dx dy, and this x1, x2, y1 and y2, these are constant, so f of xy. So eventually you will solve in this particular manner, that is dx and then dy, or that is provided the limit of integrations are changed accordingly. So x1, x2, y1, y2, f is a function which contains x and y variables, and then see this order, then it becomes dy and dx. Now in case 2, if x1, x2, suppose if x1, x2 are functions of y, suppose if this x1 is some function of y, that is x is in terms of y, and this our upper limit is also in terms of some y. So let us consider x1 is equal to phi1 of y, x2 is equal to phi2 of y, and let y1 and y2, right? So this y1 and y2 be constant. Then what will, how do you evaluate this integral? That is double integral, that is double integral over the region A. F is a function of xy, dx dy, which is equal to, since whatever is given the constant, you write it first, that is y1, y2. And see here, x1 is equal to, so this turns out to be, so this is in terms of some function in y, and x2 is in terms of, that is some function in y. So see, whatever this x is in terms of phi of y, and x2 is also in terms of phi of y. So the order turns out to be, that is whatever the function is, it should be always integrated first with respect to, that is dx, right? And similarly, what do we have if y1 and y2 are functions of x? So let me consider y1 is equal to phi1 of x and y2 is equal to phi2 of y, and let x1 and x2 be constant. Then what will happen to the change of course? It will be again, that is integration of, that is x1, x2, y1, y2. So y1 is with respect to some function, that is phi1 of x, and y2 is, that is phi2 of x, and then you have to see this order, right? So it is dy and dx. Okay, now we shall start with the problems of double integral. So let us see, the first problem is given by integration from, that is 0 to 1 and 0 to 1. It is dy by dx, and then it is square root of 1 minus y square and 1 plus x square. So this type of problems, how to solve it? So what I do is first write, that is solution, let I is equal to, you write the given question. Now have an observation here 0 0 1 1. So these are not any variables, these are what, it is nothing but these are constants. So I should use which case? That is case 1. So this turns out to be, I can take any of the integral. So it turns out to be 0 over 1. Then see here, this part, that is 1 divided by 1 plus x square, right? So this turns out to be, so here, so what is integration of 1 divided by square root of 1 minus y square? So integrating with respect to y. So this turns out to be sine inverse of y, right? And see here, what are the limiting values? That is 0 to 1. So did I integrate it with respect to x? No. So dx remains as it is. And what I use case 1, right? So see here 0 to 1, this integral is still there with respect to dx, and what I have done, I have integrated with respect to, that is some part, that is dy. So that is integration of 1 divided by 1 minus y square dy is equal to sine inverse of y. Is it right? So therefore 0 to 1, 1 divided by 1 plus x square, I keep it outside, and that is sine inverse of y over the limit 0 to 1 dx, right? So which is equal to integration from 0 to 1, right? And then it is 1 plus x square. What is, see here, sine inverse of y, upper limit is, that is pi by 2, minus lower limit sine inverse of 0, that turns out to be 0, and it is dx. So what I do is, I take this pi by 2 outside, then integration from 0 to 1, 1 divided by 1 plus x square dx, which is equal to pi by 2, right? So what is integration of 1 divided by 1 plus x square? It is tan inverse of x over the limit 0 to 1, right? And what do you mean by that? Is tan inverse of x is what? So tan inverse of x is pi by 4. So upper limit is, that is pi by 4, and this turns out to be 0. Therefore your answer turns out to be pi by 8, right? Fine. Okay. So at any instant, if I am going fast, so what you need to do is, you need to pause the video, and any queries you can directly contact me, right? Okay. So let me move on to the next problem, that is integration from, that is 0 to a, 0 to b, and the given function is x square plus y square. So this is my function in terms of x and y, okay, dx dy. So solution, right? So I is equal to, right, so 0 to a, okay, and 0 to b, x square plus y square. So what is the order? Either I may take dx or dy, right? So what I do is, it is dy, fine, and dx, right? Okay, so therefore which is equal to integration from 0 to a, okay, and then this turns out to be with respect to y. So see here, this is x square, integration of 1, that is y, plus y cube by 3 over the limit 0 to b, and it is dx, which is equal to integration from 0 to a, this is upper limit bx square plus b cube by 3, and whatever value you are going to substitute it for y, that turns out to be 0, so I do not write it up, and this thing I keep it as it is. So which is equal to, now if I integrate this, this gives me b into x cube by 3 plus b cube by 3 into x over the limit 0 to a, and then this will turn out to be, that is b a cube, this particular thing, when I substitute for it for upper limit, b a cube divided by 3 plus b cube a divided by 3, and if I substitute this here, it obviously turns out to be 0, which I do not write it. Therefore, in much more simplified manner, I can write it in the form of 1 by 3. I take it outside. A and B also I can take it outside. A square plus B square. Or else if you write till here also, it is valid. So this turns out to be your solution. Okay, let me have one more problem. That is the fourth problem. So it might be given as evaluate integral over the limits, that is 0 to 2 and 0 to x square, e raised to y by x dy dx. Now let me write it solution. So first thing is let I is equal to, right? Now see here, when I write, you write this first, and which with respect to what you need to integrate first, that you need to decide, right? So first have an observation. Now this time it is not the constant. See here the values are 0 to x square, which is a function, that is x is a variable, and 0 to 2, this is a constant. Now how to choose your dy or dx? And at a certain instant this might also been given as dx dy also, right? So what it is, see, this is in terms of x, so obviously this is y is equal to 0, and this is y is equal to x square. So this is of the form y is equal to phi 1 of x and y is equal to, that is phi 2 of x, right? And this obviously it is x is equal to 0 and x is equal to 2, and this is my function in terms of y by x. So see, this is y, so obviously I will take it with respect to dy and then integrate it with respect to dx, right? So which is equal to, that is integration from 0 to 2, that is x is equal to, and I will integrate this first, that is with respect to, that is dy. So this will give me e raised to y by x over 1 by x. 1 by x turns out to be constant. So over the limit y is equal to 0 to x square. It is 0 to x square. I have written it in this particular manner, and with respect to, that is dx. So x is equal to 0 and 2. So this 1 by x, I will write it here, x, and it is upper limit, that is substituting this in place of y, right? Because we have evaluated with respect to y. So this turns out to be ex square divided by x minus e power 0 into dx, which is equal to integration from x is equal to 0 to 2 x. This x and this x gets cancelled. So this turns out to be e raised to x minus 1 into dx, which is equal to, that is x e raised to x minus, right? Minus, that is e raised to x minus. So I need to integrate this, okay? Sorry, that is with respect to x into e raised to x. So this is integration by parts. So I multiply this x into e raised to x. So this turns out to be x e raised to x minus x square, it was right, and this is nothing but x into 1. So after evaluating this, you get, that is e raised to x 1, that is x square by 2 over the limit x equal to 0 to 2. So this will give me, that is 2, that is upper limit e square minus 2 minus, this is your upper limit minus, and then it turns out to be e square minus, that is, sorry, it turns out to be x. I need to substitute the value here. It turns out to be 2 square divided by 2. This turns out to be a lower limit, right? Sorry, this is complete upper limit. I am extremely sorry. This is upper limit, and then this turns out to be 0 minus. So anything power, this turns out to be 0, this turns out to be 0, the whole term turns out to be 0, so it is 0 over here, minus anything power 0, so inside the bracket 1, minus this turns out to be 0, right? And finally, after evaluating, you get e square minus 1, right? Okay, so let me tell you how this simplification has been done. That is x e raised to x minus 1. That is integration by part. This is first function, okay, and this is second function using the property of highlight, or also by that is Lie rule, right? See here, so let me do it by di method. So d and this is I. Fine. So my function is x, and here it is e power x minus 1. Fine. So the next, if I differentiate this turns out to be 1, right? And if I differentiate this one, it turns out to be 0. Now if I integrate e raised to x minus 1, this will give you e raised to x minus x, right? And then e raised to x minus x square by 2. So what I do, I make this arrow crosswise, right? And what I do, I always start plus minus whatever the value might be here, and this is plus. So plus is plus, so this turns out to be x into e power x minus x. So x into e power x minus x, right? Minus, so here it is minus, so I have written minus, right? 1, okay, 1 is already here, so I did not write it up, and e raised to x minus x square by 2, and finally it is 0, so there is no chance of writing it. So over the limit 0 to 2, and then upper limit minus lower limit, and finally when you evaluate, you get this particular answer, right? Fine. Now let us move on to one more question, and that question is evaluate integral xy dx dy over the positive quadrant of the circle, that is x square plus y square plus equal to a square. So first, students are required to read the question properly and see here. So it is given, that is integral over the region, that is and with respect to the given function xy over the positive quadrant of the circle. So what you do, you always should have a habit of drawing a rough sketch. So it has been given, that is, this is a circle, right? This is your y-axis, this is your x-axis, and what they have said, positive quadrant. So this turns out to be my positive quadrant. Either you can take a vertical strip or you can take a horizontal strip to evaluate this particular problem, right? And I need to find this particular area of the region. So let me consider the given equation, that is xy dx dy, which is equal to. Now in the concept of line integral, in the previous classes, I will write it here because already this sum has been done. So in your +2 classes, what you used to do, so if this is a curve and this is the area under the curve, right? Fine, and you need to find the area, right? So this is some small x of x and this is y, so length into breadth, so integral of, so this turns out to be y dx, right? If you are taking, that is vertical strip. Similarly is the case of horizontal strip, so this turns out to be x dy. Now here we have double integral dx dy. Either you can take dy first or dx first. So that is, which is equal to, if I take this so this turns out to be x equal to, right, and y is equal to, see here, what is the value of, I will take, that is 0 to, see this is a circle equation, that is x square plus y square is equal to a square. A square is the radius, therefore r is equal to a. Either you convert this y in terms of x or this x in terms of y. So what I will do is y square is equal to a square minus x square, right, and y is equal to square root of a square minus x square. So what I will do is, I will take this 0, and if I am converting this in terms of x, so this turns out to be a square minus x square. So I am converting this into y is equal to 0, that is any point on this x-axis, therefore y turns out to be 0 over here, and this curve, right, this turns out to be, since it is in terms of, I am taking it in terms of y, so this turns out to be y is equal to square root of a square minus x square. And then the other thing, that is x equal to 0, this is from 0, 0 and till what distance? So the radius is a, that is a. So your coordinates point will be from, that is with respect to this given curve, that is quadrant of a circle, right? It turns out to be y is equal to 0 to y is equal to square root of a square minus x square. This can be, the course can also be changed, right? Then x, y, dx, dy, right? Now please tell me what should be the order of this integration to be followed. Since it is y is equal to 0, so I will integrate it with respect to y first and then dx first, right? So which is equal to integration from x equal to 0 to a. X I am keeping it constant. I am only integrating it with respect to y because I am having my function in terms of y is equal to 0, which is my case 3, right? So this is y square divided by 2, that is y is equal to 0, and square root of a square minus x square into dx. So which is equal to, that is x equal to 0 to a x, right? So upper limit, if I am substituting here, that will give me this square root and this square root gets cancelled. So this turns out to be a square minus x square divided by 2. Since y is 0, so there is no need to substitute for it, right? Which is equal to 1 by 2. Integration of x equal to 0 to 2. Now this is, if I multiply this turns out to be x a cube minus x cube into dx, right? So which is equal to 1 divided by, if I take the integration of that particular thing, that is integration of 0 to a, that is x a square minus x cube it was, right? And dx, right, which is equal to 1 divided by 2. Now if I integrate it, so this turns out to be x square divided by 2 a square minus x by 4 divided by 4, and this is 0 to a, which is equal to, that is 1 divided by 2, that is a square into a square, that is upper limit. Obviously the lower limit when I substitute it turns out to be 0 minus a power 4 divided by 4, which is equal to a power 4 divided by 8, and this turns out to be our output. Okay, let me have another problem, and that is I hope it is, I do not know the number now. Okay, so what I need to do is I need to evaluate the given integral over the limiting points, that is 0 to, that is a cos theta, and 0 to pi, r sin theta, dr d theta, right? And let me write the solution. So let me consider I is equal to, in the previous example we had the variables x and y. Now I am having in terms of r and theta. Same procedure will be followed. Now I have to look on, now let I is equal to 0 to pi, and it is 0 to, that is a cos theta. So the given variable I can choose it, that is r sin theta d theta dr first. Why? Because this, or d theta by dr. Okay, so this is in terms of r is equal to, and this is in terms of r is equal to. So I will choose, I need to dr d theta, because this 2, right? So 0 to pi. At any instant, if this is given as d theta by dr, that time you have to observe this two things, right? If it is again given, then only you have to follow this order. Do not take d theta first, right? Because it is in terms of r is equal to 0 and r is equal to cos theta. So when you evaluate this, you get, that is integration from 0 to pi sin theta, that turns out to be outside, and with respect to dr, so this turns out to be r square divided by 2, this r, right? And over the limiting values, that is upper limit is a cos theta into d theta, right? Which will give you, that is 1 by 2, I will take it outside, this 2, right? And this is 0 to pi, and here this is a, so it turns out to be upper limit a square cos square theta into sin theta into d theta. Now what I do is, to avoid complications and to make it much more simplified, I will take, if I put cos theta is equal to t, that is by substitution. So after differentiating this with respect to theta, so this turns out to be minus sin theta d theta, which is equal to dt. Okay, so which is equal to integration from 1 by 2, I will write it as it is. I have to change this limits also. So this turns out to be, that is a square, right? What is cos t? It is t. So this cos t theta will be my, that is t square. What is sin t dt? But here it is minus, so I will take this minus sign outside. So what is this sin t dt? It turns out to be dt, which is equal to, okay fine, now I have to change the limit. See here, for this particular thing, if I substitute, this is theta, right? So because theta is varying from 0 to pi, if I substitute theta is equal to 0, so what will happen to t? It will turn out to be 1. So this turns out to be 1 now, right? If I take this cos of pi, so using allied angle, so it becomes 90 plus 90, so it comes in the second quadrant. So here cos of pi, it turns out to be what? It is minus 1. So this turns out to be minus 1, right? So this is, see here, now this is minus 1 by 2, 1 over the limit minus 1 to 1 a square t square dt, that is after substitution. Now you know by one of the property, that is if I change the limit points, then it is transformed by negative sign. So this negative and this negative sign, it turns out to be, that is integration of if it is a to minus a f of x dx. So if you change the limit, that is minus a to a, and this turns out to be minus f of x dx. So this minus, so what I will do, this turns out to be a square by 2 integration from minus 1 to 1 into t square into dt. That minus sign and minus sign, it becomes plus, right? So now this turns out to be, which is equal to, that is a square by 2 over the limit t cube by 3 minus 1 to 1, which is equal to a square divided by 6, right? Upper limit is 1, it becomes plus 1, which turns out to be a square by 3, and this turns out to be an answer. Okay, so let us have another problem, and it is question, so evaluate the integral x by x plus y dx dy over the area between y is equal to x square and y is equal to x. Now first thing is, before solving this, first read the question properly. So it has been given that evaluate the double integral x by x plus y dx dy over the area between, these are the curves, y is equal to x square and y is equal to x. So first thing is, you need to draw a rough sketch, right? So let me draw this for you. Fine. Y is equal to x, it is always at 45 degrees, right? So this curve is y is equal to x, and obviously y is equal to x square will be this, right? So this is nothing but y is equal to x square. Fine. Now first thing is, you need to find, let me write this y x, find the point of intersection, right? I need to find the area with respect to this function, right? So let me consider this as solving. Okay, so I need to find the point of intersection first, right? So what I'll do is, let y is equal to x and y is equal to x square be these two equations. Let me consider this as equation 1, this as equation 2. So what I do is, on solving we get, what do we get, right? So this is nothing but, that is, I will write it as x square is equal to x. If I equate these two things, so or solve this, I will get x square is equal to x. So which implies I take this x to the left hand side. So this is x, right? X square minus x, okay? Which square minus x equal to 0. Now which implies x minus 1, which is equal to 0. So which implies either x is equal to 0 or x is equal to 1. So you have 2 points. So x, here it is obviously 0, 0. So x is ranging from, that is x is equal to 0 to 1. Fine. Now since x is 0, what will happen to y? It will be 0. Since x is equal to 1, what will happen to y? It will turn out to be 1. So obviously this particular point of intersection, so whatever it is, the point of intersection between these two lines, y is equal to x square and y is equal to, this turns out to be 1, 1. Right? So the points of intersection are, therefore, the points of intersection are 0, 0 and 1, 1. Therefore, the integral xy x plus y dx dy is equal to, see what is the value of x? X is 0, 1, that is, it is a constant, and the other values are, see here, it is ranging from, so see here, this is x-axis and this is y-axis, right? So y is ranging from what? That is this particular curve to this particular curve. So this is x square, so it is in terms of y is equal to x square to y is equal to x. And what is happening to the x-axis? That is 0 to 1. So x is 0 to 1. Now which is the order you are going to choose first? Okay, so it is in terms of y. So first order you are going to choose, that is order of integration, that is dy first and then dx, that is this, and whatever your function is, that is x plus y, right? And then what you do is you need to integrate this with respect to y first. So which is equal to integration of x is equal to 0 to 1. This is x square, right? Because I am multiplying this, and this is y square divided by 2 plus x y square it becomes, so it becomes y cube divided by 3 over the limit, that is x square to x into dx, which is equal to integration from 0 to 1 x power 4 to 2, right, plus x power 4 to 3 minus upper limit minus lower limit 2 minus x power 7 to 3 into dx, and which is equal to, so this is everything I have written in terms of x, and then this is again integrating 2 plus x power 5 3 into 5, yeah, minus x power 7 2 into 7 minus x power 8 divided by 3 into 8 over the limit 0 to 1, which is equal to 3 by 56, and that turns out to be your answer. Okay, now we shall see that is next example, and next example is evaluate double integral, that is r cube dr d theta over the area included between the circles r is equal to 2 sin theta, r is equal to 4 sin theta. Okay, so first thing is, what did I say? Read the question properly and then start solving. So what is been given? So double integral r cube dr d theta. Now the function is in terms of r and theta. So f is a function which is in terms of r and theta. The earlier problems were in terms of x and y. And with respect to dx, dy, here it is dr d theta, whatever might be the order of integration, right? And now first thing is included between the circles, r is equal to 2 sin theta and r is equal to 4 sin theta. So first thing is, you should know, that is how to draw a rough sketch, right? So let me draw a rough sketch for you, right? So see here, let me draw this axis. Fine. Okay, now This is r is equal to 2 sine theta. Now please tell me what is so r. This is my x-axis, this is my y-axis. So r is at a distance, that is 2 sine theta. Sine of 0 is this. Okay, what is sine of 90 degrees? If you substitute, sine 90 is 1, right? But it is at a distance what? It is 2. So 2 units you take over here. So since it is a unit circle, so this turns out to be a one circle, that is of r is equal to 2 sine theta. Now r is at a distance 4, so obviously 0, 0. So 1, 2, 3, 4. So this turns out to be one more circle. Fine. So this is how we draw a rough sketch. Now see here, between the circles, so I need to find the area between these two circles. So what I do is, let me consider this as I is equal to integration from, let me write this r cube d, okay, right? I will not write what with respect to theta or dr, right? Now what is happening to r? R is in terms of what? R, this is a circle in terms of r is equal to, that is 2 sine theta, and this is the circle, this is the curve, r is equal to 4 sine theta. So let me write this first, that is r is equal to 2 sine theta, this curve, and this r is equal to, that is 4 sine theta, and the remaining one is the constant, that is what is happening to theta. Theta is revolving from what? 0 to, it is revolving till, that is pi, right? So it is theta is 0 to pi. Now see, this is r over here, so I will obviously integrate it with respect to r first and then with respect to theta. So which will give me, that is 0 to pi of this theta, and if I integrate this with respect to r cube, so this will give me r power 4 divided by 4 over the limit to sine theta, 4 sine theta and d theta, which will give me, that is 60, right? 60 integration of 0 to pi sine 4 theta into d theta, right? Okay, and then okay, so it is 0 to pi. Now one of the property, that is 60 into, I can write it as 2 times of 0 to pi by 2, because I want to make this much more to make the calculation much more simplified manner. So I will take it 0 to pi by 2 sine of 4 theta into d theta, right? And yeah, now this type of integrals, that is any integral of the type, that is 0 to pi by 2 sine power n theta d theta, depending upon this n, that is we can make use of, that is reduction formula, and I have already given you in the notes, that is how to solve reduction formula by making use any integral of the type 0 to pi by 2 sine power 4 theta d theta by making reduction, that is giving it output with the use of reduction formula. So this turns out to be 120 into 3 by 4 into 1 by 2 into pi by 2, which will give you 45 divided by pi, right? Pause the video and then check out, right? So for your homework problem, you people try it for r is equal to 2 cos theta and r is equal to 4 cos theta, right? Fine. Okay, fine. So next question, I will write it for you. Sorry for the interruption, there was a technical problem. Okay, so the next problem is evaluate integration of, that is double integration of r sine theta dr d theta over the cardioid, to which you are very familiar, which is equal to a1 minus cos theta above the initial line. So solution, right? So before writing up the solution, first you should know, you should have the habit of drawing a rough sketch, right? So see here, how does a cardioid look like? First draw all this x, this is my y, right? So the cardioid, since it is 1 minus, so always it is towards the left. Sorry, I am not that good at drawing. Fine. You see here. So so I need to find the point of intersection as well. So what is happening to theta? See, this is at 0, right? So if I take the radial axis over here and it moves like this, since it is in terms of r and theta. Fine. Yes. So what is happening to the theta? So all the points will be here, any point, and my theta will be from, that is, my theta is, this is my theta, and theta will be always from 0 to, that is, theta is equal to pi. Why till pi? Because it is given above the initial line, right? So what is being given? R is equal to, so R is what? R is equal to, that is, so what will be the radius over here? So it will be from 0 to, that is, R is equal to a1 minus cos, that is, cos theta, right? So first thing is, let me turn up my page and then I shall. So this is the figure. If it is 1 plus R is equal to a1 plus cos theta, so the figure for this turns out, it will be in this particular manner, that is, right? So this time it turns out to be, again, theta is from what is happening for theta, that is, okay. So this is R, and that is R is equal to a1 plus cos theta, right? For a cardioid, no, not cardioid, okay, yeah, this is cardioid, right? Let me turn up the page. Okay, so write the solution, that is to integrate first with respect to R. So the limits are, that is, R is equal to 0 to any point P, that is to P, that is R is equal to a 1 minus cos theta. See here, R is not uniform, right? From year to year, year to year, year. It differs, right? This is the curve wherein R differs everywhere, right? So R is from 0 till what? R is equal to, that is a 1 minus cos theta. And what is the value of theta, right? To cover the whole region, that is R is covering the whole region, that is upper half of the, that is above the initial line, right? And then theta varies from 0 to pi. Therefore the integral of sin theta dr d theta is equal to, that is 0 to pi, and this is 0 to a inside the bracket 1 minus cos theta. So this is R is equal to, because this is in terms of theta, and this is theta is equal to, right? And this is R sin theta d theta, sorry, dr, because here it is R, so dr d theta, which is equal to integration from 0 to pi sin theta with respect to r, this turns out to be r square divided by 2 over 0 to a1 minus cos theta here into d theta, which is equal to a square. Let me adjust it properly. Yeah, a square divided by 2 integration from 0 to pi 1 minus cos theta square into sin theta d theta. Right. So this turns out to be, that is, which is equal to a square divided by 2. Okay, so this turns out to be integration from, okay, now if I take 1 minus cos theta is equal to, that is 1 minus cos theta is equal to t, and then if I differentiate this with respect to theta, right? So what will happen? Let me see. Now this turns out to be 1, that is 0, that is minus cos theta, it turns out to be sin theta d theta, which is equal to dt, right? So I can write it as okay, now so this turns out to be, okay, now if I substitute 0, cos of 0, theta is equal to 0, this turns out to be 0, so t is equal to 0. Now if I substitute the upper limit here as pi, so cos pi is minus minus becomes 2, right? It turns out to be t square. What is sin theta d theta? So this sin theta d theta is nothing but dt. So a square divided by 2, this turns out to be t cube divided by 3, 0 to 2, which is equal to a square divided by 2, and this turns out to be 8 by 3, which is equal to 4a square divided by 3, and that turns out to be your answer. So in the next class, what we'll do is we will solve few more examples which are very useful, right? So these were all about your basic classes, right? Tomorrow we shall see the next thing, right? Fine. Thank you very much.